Welcome back to another video of Learn with Vishrant, and today we'll be learning sweetening emission source. Okay, so we are in this part of emission source from where the leakage might happen in air pollution, and in this topic we are in sweetening emission source. So let's learn about this. Okay, sweetening of distillates is accomplished by the conversion of mercaptans to alkyl disulfides in the presence of a catalyst. The major emission problem is hydrocarbons from contact of the distillates product and air in the air blowing state. So whenever there is a air blowing state, so the air can leakage from that source, right? So this is the major problem in this sweetening emission source. These emission are related to equipment type and configuration, as well as to operating conditions and maintenance practices. So next one is asphalt asphalt blowing emission source. The asphalt blowing process polymerizes asphaltic residuals oils by oxidation, increasing their melting temperature and hardness to achieve an increased resistance to weathering. Air emission from asphalt blowing are primarily hydrocarbons vapor venting with the blowing air. If I'm not wrong, asphalt means that Alcatra, ASPLAT. Sorry. They are showing all the games and everything. Sticky, yeah, is a sticky black high viscous liquid. So these are all from crude wells, and this is one of them. So yeah, obviously, right? So the emission, the whatever the whenever it is heated and whatever the vapors comes from it, and it's primary hydrocarbons vapor vented with the blowing air. The quantities of emissions are small because of the prior removal of volatile hydrocarbons in the distillation unit, but the emission may contain hazardous polynuclear organics. Emissions are 30 kg per megagram mg of asphalt. Emissions from asphalt blowing can be controlled to negligible level by vapor scrubbing, inclination, or both. And we'll learn two more topics: fugitive emissions and control. Fugitive emissions source includes leaks of hydrocarbons vapor from processes, equipment, and vaporization of hydrocarbons from open areas rather than through a stack or vent. Fugitive emission source includes valves of all types, flanges, pump and compressor seals, process drains, cooling tower, and oil or water separators. Fugitive emission are attributable to the vaporization of leaked or spilled petroleum liquids and gases. Normally, control of fugitive emission involves minimizing leaks and spill through equipment changes, producer changes, and improved monitoring, housekeeping, and maintenance practice. Valve, flanges, seal, and drains emission source. So these are the main areas I think from where the leakage happen mostly. For these sources, a very high correlation has been found between mass emission rate and the type of stream service in which the source are employed. Correct, yeah. So bulbs, because of their number and relatively high emission factor, are the major emission source. This conclusion is based on the analysis of hypothetical refinery coupled with the emission rates. The total quantity of fugitive VOC emission in a typical oil refinery with a capacity of 52,500 meter cube per day is estimated as 20,500 kg per day. This much for today, and we'll learn more in future topics. Alright, so thank you for watching, and please subscribe, like, and share this channel, because I'm learning with you guys. We are learning together, so don't think otherwise. Okay, thank you so much. Subscribe.